Okay, today's talk is going to be TypeScript for React developers. And before I start with that, I'm going to tell you a little bit about me, the guy on the front. My name is Lenz. You can find me on Twitter as Fry. You can find me on GitHub or just everywhere else as Franiers. And I'm currently working for 4 years now at Mayflower, where I'm very happy. I've been doing PHP since PHP 4, so a little more than 15 years. I've started with JavaScript back in 2013. I mean, I was already using it before, but there's a point where you really start to use the language instead of just writing some scripts. And for me, that breakthrough moment was somewhere in 2013. I've been using React since 3.5 years now, and I'm using TypeScript almost as long, a little more than 3 years. You can find me in many open source projects on GitHub. Most relevant for this talk is ForkTS Checker Webpack plugin, which is a plugin for Webpack which does type checking of your TypeScript code. If you are using Create React app with TypeScript, this is running in the background, and I'm one of the contributors there. Also relevant for this talk is Redux Starter Kit, because I did a lot of the types for Redux Starter Kit, and this actually is a part of one type definition in Redux Starter Kit. This is not to scare you away. Library code in TypeScript might look like that, but your production code definitely shouldn't look like that. Also, I'm working on React Async, and we just finished porting that to TypeScript from a pure JavaScript perspective. And also, in the last few months, I've started using PostgreSQL, and I also started contributing to PostgreSQL. And as for slides, unfortunately, that's it, because I'm not the person who should have done this talk. That would have been Hans Christian Otto. But he got sick this morning, so I just jumped in and said, okay, I can do such a talk, but I haven't prepared such a talk. So this will be a lot of live coding without any preparation, or just a little bit of preparation. So a lot of it is absolutely guaranteed to go wrong. If you see me doing something stupid, please tell me that I'm doing something stupid. You can place bets on how much stupid stuff I'm going to do. And everything we are going to do today is going to live from what you input into it. I'm going to show off some things, and I want you to ask questions. I want you to make me repeat myself if I'm going too fast. I want you to tell me that I should explain something deeper. I want you to tell me that I missed a topic that would be of interest for you. And with that said, I think we'll just start into everything. At first, some theoretical things about TypeScript. Is anybody here already using TypeScript? Well, that's just about more than half of you. So I guess you already know many things. For you, what are benefits of using TypeScript? Type checking and IntelliSense. So we have static tests, is essentially what type checking is. And on the other hand, we have developer experience. And those two things are, for me, the key reasons to use TypeScript. And as we're going to see, the one sometimes bites the other. The better types you write, the better IntelliSense you get, but also the more painful those types are going to get. Because that's the point where you always have to make the deal with yourself on not writing too extensive types, but just the types that help you to solve your problem. TypeScript builds on top of JavaScript. A few years ago, people would have said classes are a TypeScript feature. Classes never were a TypeScript feature. Classes already back then were in the JavaScript specification. They were a ES6 feature. And TypeScript just builds on top of that. There is actually one feature in TypeScript that's not a JavaScript feature, and that's enums, but everything else that's in TypeScript is also a JavaScript feature. So there is a compiler for TypeScript, and that compiler essentially just goes ahead, checks all types, then removes them and puts out the code, and that's your transpiled JavaScript code. Of course, the TypeScript transpiler can also transpile down to an older level of JavaScript. If you need ES5 code or ES3 code, it will do that. But if you just set the compiler target to modern JavaScript, it will just take your TypeScript code, remove the type annotations, and you have JavaScript code. And it has always been a target of the developers of TypeScript to make that transition, because the code that's output that way is readable. It's indented like it was before. It can be auto-formatted if something went wrong, but it's already readable JavaScript code, and a human can really read that and continue to edit that. So if you are going into TypeScript, you're not vendor locked in. If you start using TypeScript and you notice, okay, this isn't for me, then you can just decide, okay, I'll transpile it once to a modern JavaScript dialect, and then I'm going just to write JavaScript in the same files as I was writing before. So you can try to use TypeScript without any dangers whatsoever, and if it doesn't suit you, well, that's a shame, and I guess if you would spend more time, most of the people would start to love it. But if you really notice it doesn't suit you, it slows you down or anything, you can just stop using TypeScript from today to tomorrow as well. And this is a very powerful feature of that language, and it's always been a design target. That said, let's just look at some JavaScript and at some TypeScript. I'm going to start a new project here. And I'm doing a create React app without TypeScript at first. So we have a starting point where you might already be with an application that doesn't have TypeScript included. And then we look at how to integrate TypeScript with that and how to use TypeScript with JavaScript files, not TypeScript files. That's possible too. And from then, we're slowly going into TypeScript. We are at the IJS, and we're doing a talk on React with TypeScript. This takes a while, but, well, hopefully not too long. Yeah, there we are. I don't want to update right now, not on a conference Wi-Fi. And now we have a standard React application. Everything is JavaScript files, and, well, what we can do here is do something like let x equals 5, and then we can say x equals 5. And this is valid JavaScript, and not like that, but this might be something you might encounter in the wild, and that leads to bugs you have. This is very weakly typed. It can just change the type. It doesn't mean that there aren't any types in JavaScript, because they are primitive types. There's a Boolean, there's string, there's number, there's object, there's null, which is also a type, but if you do type of null, you'll get object, which is a little weird. And then there's undefined, which is also a type. There's also symbol, which is pretty new, but in everyday code you aren't likely to use many symbols, so we aren't going to talk about those too much. Well, this definitely is something that's an error. IntelliSense also tells me here that this should be a number, but right now it isn't. And let's introduce TypeScript to this project. Just for fun, I create one test.ts file, And as soon as I have one file with a TypeScript ending in my whole Create React app project, when I try to yarn start it, it will complain the TypeScript isn't installed. Or even worse. Yeah, it even thinks it has TypeScript, okay, and it hasn't, so that's even worse. What we need to do to make this actually work with TypeScript is to install TypeScript. So we'll add that to our project. Besides adding TypeScript to our projects, we also would need to add type definition files for React to our project, because React itself isn't written in TypeScript, and React is distributed as pure JavaScript. And if you want to use an external library from our TypeScript code, we won't get any information on the types in that library, except if we install the types for that library. So with every other setup, we would have to do yarn add types. Those are scoped. React, and that would install us the types for React, but Create React app already comes with those. So if we ask yarn why types React, we couldn't find a match, but it's going to work, I promise. Weird. Well, okay, let's go on. We have TypeScript installed in our app, and we want this, still in a JavaScript file, to be somehow checked and to somehow warn us as users. What we can do in every JavaScript file, as long as we have TypeScript in a scope, we just can add a header that's ts check. And that will enable the TypeScript compiler to also check this file for errors. So first complaint is we do not have types for React. I was obviously wrong on that, and we need to install those. I tried it earlier and I could have sworn it worked without, but okay. And now it says, okay, we have typings for React. And the other thing in this file that has been checked now is this, that we are assigning a string to a variable that has been declared as a number. And this has automatically been declared as a number because we initialized it as a number. We could also tell TypeScript still in our JavaScript file that this would be a string. And I haven't done this in a long time, but usually it should do the trick. Or maybe like this. Yeah. No. Okay. There is a way to work with JSDoc. Obviously, I haven't done that in a long time. But if you're going into a existing project and you want to transition over to TypeScript, and you haven't completely bought into the idea, I will tell you, you should go and look this up and do it the right way. Obviously, I didn't. Because this can also add a first level of type checking into your existing JavaScript code. If we don't want to do it this way, but we really want this to be TypeScript, we can remove this tscheck annotation and just rename our file to ts. Or rather, as this is a file that contains JSX, and JSX in TypeScript files is per default not transpiled, we have to call this file tsx for TypeScript with JSX. And from now on, we're in a TypeScript file and we got the same thing that we had before. Thing is, now we can write types here and we can tell it, okay, x should be number or string, and the arrow should go away. So this is something we can do now. We couldn't before in the JavaScript file because there it was just somehow interpolated and was throwing errors. But we're at least 2 steps ahead of everything right now, because as we did the yarn start here, it noticed we have TypeScript and it generated a tsconfig JSON for us, which is this configuration file. And this configuration file is the configuration file for the TypeScript compiler that tells it a few things. It tells that we have a transpilation target, so every code we write will be ES5 in the end. This should be able to run in Internet Explorer. And also that we have some libraries that should be preloaded for our type completion, and that we don't get errors when we try to use those libraries. In this case, we want to have access to DOM functions, etc. We have this allow.js, which I was just using by doing the TS check in the top. This is just for speed. This is for convenience, as is this. This is important. This is strict mode. If you initialize a TypeScript application by using TSC, the TypeScript compiler binary, in it, it will also create a tsconfig JSON for you. And this might sometimes, depending on the TypeScript version you are using, be false. And then you won't have checks for undefined or null, which really might hide a lot of bugs. So I would suggest that you always start with strict true and always keep to strict true. This might feel a little clumsy in the early moments, because it always tells you this could be undefined, please check if it's defined, this could be undefined, please check if it's defined. But after a while you'll get to notice, yeah, and there's a reason for that, because it could be undefined and you could be running into a bug. So this really helps you. This tells to which kind of module it should compile to. And this tells us that we are using React as a JSX pragma here. If someone is going to use Preact or a Hyper app or something, those usually don't use the React create object notation, but those use the H notation. And in that case, you would just change this out to preserve and put another transpiler like Babel behind that. So we've seen where TypeScript gets it gets configured. This is important knowledge for us. And we've also seen that TypeScript warns us if we try weird things, but we haven't really seen how to actually use it. But I already did, and I did it in the best way. I did it by not using TypeScript. If I'm declaring my variable and just assigning something, TypeScript does its job. I don't have to. And doing exactly just this will give you the best results, because I have here let my variable and I declared it to be 5. And this will be inferred as a type number, because I declared a 5 and maybe I want to declare it 6, 7, 8 or something in the future. If I do a const assignment here, this will not be the type number, but the type number of value 5. So this. And this means that the TypeScript compiler is doing inference much closer to the reality of the software you're writing than you are doing yourself actually. You might want to declare something like this is a number to loosen it up if you need to, but usually you don't want to. And the main thing, if you take one thing out of this talk today, is that you don't want to specify types if you don't have a good reason for it. There are points where you should specify types. We are going to talk about those. But variable declaration usually is none of those. So I was using the word type here a lot. And we've seen the type number, the type string. We already know there's Boolean and object and symbol from JavaScript. Obviously, this is 100% compatible to JavaScript, so those also all exist. And there are a few other types that you will see. There's a type that's called unknown. And this is a great type if you're interacting with some API but haven't checked the result of the API yet. So you just say, okay, we got something from the API, but we aren't really sure what it is yet. Then you do your tests, and then you can assign your unknown value to a variable that has a type, that has the type that you just checked for. And in between, you don't accidentally use that variable. So unknown is something that can be cast to everything else, but it can't be used without casting, which is enormously useful. The opposite to an unknown type would be the any type. This also can be cast to everything else, and it can also be used as everything else without even casting it. So I could use this variable as method argument where it would require a string or an object or something. So this is something you can do as a last resort escape hatch if you don't know how to correctly type something. And I actually really say you can do that and you should do that. If you notice, writing TypeScript here gets too complicated. But if you resort to any, you have a very good indicator that the code you just wrote maybe needs 2 or 3 more tests than every other code you're writing. But there might be linters that say every any is wrong. I don't agree. Any is a great tool if you use sparingly and knowingly. Then there are 2 other types. There's the void type, which usually is just used as a return type from a method, which either means this method does not return anything, or we just don't care about the return type of the method and we don't anybody to use the return type of the method. And there's the other type that's just returned by methods, that's never, and that just means this method will never terminate. So if you have an infinite loop or something there. We have seen you can write a variable name and assign it a type here. And I also said you can do casting, which means another variable equals my variable as string, for example. This would be an explicit cast. This could also be written, but not within TSX files, with this notation. But as you see, within a TSX file, it's already interpreted as JSX, so don't do it. And actually, after the first 2 weeks of using TypeScript, I completely stopped doing this notation because it always made, I can't work with that. And I haven't seen it a lot in the wild. So I'd suggest you do the manual typing like this. And then we get to the point where we say, okay, it's for variable assignment and there's types, but how does it actually feel? What does it do in the real world? And in the real world, TypeScript is often, or most of the time, used to define interfaces between layers, method definitions. Which arguments go into my method, what are the types of those parameters, and which type is being returned. That's the most useful thing in TypeScript you'll ever have to use. So if we define a function here and call it string length, and we return, or we get 1 argument in, and we return arg length. Really not hitting my keys today. We get a warning here because we have strict mode enabled. which says implicit any type. And this means if we define something where the type cannot be inferred, like in this method argument, we never know how it will be used before actually being used. TypeScript would take this as an any, and as we're in strict mode, implicit any's aren't allowed, so we have to define the type. And the type here for this method parameter or function parameter, in this case, should be string. And now this is completely ready. This is a function that takes a string and returns a number, and TypeScript already knows that. If we hover over, it returns a number, always. This is because string.length is a number, and TypeScript takes all return paths that a method can possibly have, and already does all that work for us. You might also want to specify the return type, because I can have a function here like if math.random is lower than .1, I want to return surprise instead. And TypeScript would now say, this is a method that returns number or the string surprise. And actually, I guess if you have this in your implementation, this is a bug, and if it's a very long function, you just might miss that one return statement in the middle that does something different. So if I define my function here and say, this returns a number, then this return statement is an error. This is useful, but not overly so. In some cases, you might want to just let TypeScript figure out the return type. In other cases, you might want to really specify the return type. I'd go by method length here. If it's less than 20 lines and has only one return statement in the last line, then I don't care about it and I won't specify it. If it's very long, I might want to specify it so accidents like this won't happen. Okay. So we have seen some TypeScript here, and we are missing one last feature before we can use this with React. And this one last missing feature is interfaces or complex types. Because we will need this, that if you write a component, a function component or a class component, to define what type of props might go into that component. Because that will be something more complex. That will be one argument which has many child attributes with differing types that you want to specify. So we are going to write our interface, my props, and we say property A is a number and property B is a string. And now we can say my component is a function that has one argument. That first argument is called props, and it's of type myProps. And then in here, we just can decide we return props.b, which is absolutely valid because a string is valid JSX in this context. This might have a problem though. We have no set return type here, and we could also try to return things that aren't valid JSX. So we could try to return just props, which is an object, and React won't work with an object returned from a function, except for a JSX object. So this is not super type safe to use as a React function. And this is the reason why we can also declare React functions with types that are provided by the React package itself. So instead we could say we have a constant my component with more strict typing. And yes, I'm writing a lot of stuff here. And that is a function. I can write it like this, or I could write it like that. that doesn't matter at all. And I say this is a React.function component that receives arguments of type myProps. This is now red because we are not returning any JSX. We get that warning. If we return a test like this, it works. And this nails down the return type, which has to be JSX element now. And this is also our first use of a TypeScript generic. Generics are special types that take other types as parameters, like this React function component type took our self-written myProps type as an argument. And we could also just write this React function component type ourselves. So we would write a type myFunction component that depends on a generic type being passed in, props or something, equals a function that takes our props and returns a JSX.element. And now I have a generic type that I've written myself that does the same thing as the one from React. Essentially, there's a lot more actually that we can use in our application. But defining generic types for use in React itself is something that you won't do too much. You might do it if you have some generic props for your generic table or something, but this isn't something you'll be seeing in the first 2 or 3 days. But on the other hand, using generics that are provided by a library for you is something you'll be doing from day one, because if you look at the typings of Redux, that's actually what we were looking at. Oh, I've started another React application on that part. That image that I had at the beginning with all that big type, that was from Redux Starter Kit. And libraries have a lot of generics defined in them. If they're written good, you don't have to specify the generic type and it will be inferred automatically. Sometimes you have to do something like this. Well, yes, now we're at the point where we can actually use this in React. And there's one thing this notation of React function component cannot do, and that would be to make our own generic on the way. This is simply not possible. We would have to type the whole function then. If you ever stumble about this, I want to use a React function component or something with my own generic function, that's not possible in that way. You'll have to write the whole definition like up here and just have to specify a good return type. Something like React Node or something. JSX element is a good candidate too. If we can always jump into these types and look at what our library is doing with us. So we can jump in here and we see a React Node can either be a React child, a React fragment, a React portal, Boolean, null, or undefined. That's a lot of stuff I wouldn't think about. And if we look into React child, we see that's another deep dive. This can be a React element or React text. React text can be string or number. React element can be a JSX constructor element, and here I'm lost, totally. These are types for you to use. Some of them are for you to read, but most of them aren't for you to read. Those are there for your convenience, but hopefully you should never need to edit those. If you ever come to the point where you have found a bug in a type definition, all types that are installed using this add types prefix live in one big GitHub repository that's definitely typed. And you can just do a pull request there. By now, members of the TypeScript team themselves do weekly shifts, switching around and doing pull requests on there. So this will be vetted a little bit, and people will discuss on it, and then it will be merged, and everybody can use that. But honestly, doing TypeScript types is not the most easy and funny way to get into open source, so I would recommend to do something else. Yes. Now we have all this. With using React with TypeScript in those basic things, really React components, etc. Are you still using class components? Okay, I see some people nodding, but nobody really wants to raise their hand. That's okay. If we would write a class component with our own interface for properties, we could do the same and just say class my class component extends react.component. And now React component is the class React component that's exported by TypeScript, but it also has type definitions now, and those can be used generically. So we can just say this extends a React component with the props, my props. And now if we go into a render function or something in here, we can say this punct, let's return it have it return something so it doesn't read anymore, and we can say this dot props dot a, b, and children is also automatically injected here. So you can use those. They have the right type because it was inherited, and it works really well. The other thing that you can give as a generic here is the type of the state. So I could also write an interface, my state, and say there's some symbol on here, why ever you would want to do that. And I can say second argument is my state. So if I try to access this punct state punct something here, I get this C property. This is all fine, but in the end you will start writing React components, and especially function components, that are themselves like 3 lines long, and they are prefixed by 1 or 2 interface definitions, and that might not look appealing to your eye. It's completely okay to write interface definitions for something like props inline. So instead of doing what we did up here, we could also just say function my component, or my FC, is a function that takes x as a string property. It returns a React node, and we return a string something. This is also perfectly valid. This is an inline interface definition, or rather an inline type definition, because actually this is not an interface, this is a type. There's a small difference between interfaces and types in how they are internally used by the React compiler, by the TypeScript compiler itself. Interfaces are evaluated lazily, and types traditionally are evaluated eagerly, but since TypeScript 3.7, they will be a little more lazily. For you, that shouldn't make any difference, honestly. But you could write, instead of using this interface my state, here you could just do type my state equals C symbol, and that will be perfectly fine. Having that state here also brings us to another very interesting feature, and I honestly forgot the name of the pattern right here, but we can just try it out and figure out how it's called on the way. Discriminated union. So we are talking about something that's different and something that's unionized. What I didn't say up until now is that you can merge types and interfaces together to a new type. So when I write my everything together type here, I can just say it's my props and my state. This would be the result of something like object, assign, empty object, props, state, or something like that. So if I have a variable here right now, like ev that's from type everything together, then I can try to access ev a, b, and c, because a and b are from the props interface and c is from the state interface. So we can unionize types here. And where this becomes very interesting is if we have something like a state machine where only a few different states are really possible, and you maybe want to see in which of those states you are in. We could, for example, say state is loading and we have no additional information, or, and we can do this too, we can OR types. State is loaded and value is of type string. So if we go down into our component here, and we can try to access this point state dot, we cannot access this point state dot value, but we can access this dot state dot state, because that's everywhere, and that's our discriminator. So we can use this state, we can test it, and if it equals loading, inside of here, this point state dot value should, no, loaded. Value should be accessible. So this way you can have your own little state machine, maybe in your React component state or in your Redux state or everywhere else. And TypeScript will warn you if you assign something to a value while state is still loading. It might force you to do some more ifs than you were used to before, but you're really walking type safe here, and that's a really great pattern to do things. Equals 5. We can't assign to that because it's read-only, so yeah. That's another warning from TypeScript. Very good. We are at the 3/4 of an hour mark now, and I think I've told you just enough about React here to start experimenting with it, to start getting to your first own questions on it. Is there something on React and TypeScript without Redux, which would be the next point that I've missed until now? Because if you tell me now, I can tell everyone about it. Yes?
What about higher order components?
Higher order components are essentially just functions that are generic, that infer a lot of their generic parameters if used correctly. So I can also write generic functions. So a function that receives some type, and it receives an argument that's string and another argument that's of this type. And then we can, for example, say the return type will be this type and something extra. I think I'll need to bracket this or it will have problems here. And the something extra property on there will be string. Okay, we're inside a JSX file here. I can't write generics like this because it will always think that this generic is JSX. We can get around this by saying that this is not anything, but it actually is a type that extends the any object, empty object type. Then now this works. It's still red because I'm not returning anything. I could return now everything that was an X and something extra and something. And this is still showing up as the function has no name. Identifier. I always get the point wrong. Where to? Oh yeah, there you put it. Okay. This essentially is what a higher order component looks like, except that we say t extends react.component type, and inside here we do some modifications or wrap it into another component and return that other component. From using it, it doesn't really matter if we call this with a React component or anything else. It's just a higher order function that takes something else and enhances it somehow. So here we could say let a equals myfn, and let's return this, remove this argument that does nothing. We enter foo bar here, and this method up here takes t, extends it with something extra, and we actually get this combined type down here. And this essentially is what a higher order component does. Just with a higher order component, you probably see something like p extends anything, and comp is a React component type with p as parameter, and we return another React component type that also takes p and maybe something more of p or something less of p, because you can try to exclude arguments or you can try to include arguments in your types, and there are, well, this obviously is wrong now, there are a few helpers that we might just skim over for a second here, and those are within React itself. So if we have, in TypeScript, sorry. If you have this function here that always returns a number, then I can do something like type x equals the return type of my function x. And this will give me number here. So this return type is one of the internal types that TypeScript provides to do such magic that also helps with removing one single property from an object, adding one, making it readable or writable or anything like that. So there are these parameters types that give you all the types of all the parameters. There's non-nullable, which takes a type that can accept undefined, returns a type that doesn't accept undefined. I could go through all of these, and we'll be sitting here tomorrow. I really recommend just go into the TypeScript documentation. There's a lot of those. Those are great, and if you want to do your own higher order components, you can use those, or you will need to use those. If you just want to use higher order components, if the higher order component is written good, and if everything that you put into your higher order component is approximately accurately typed, then you won't have to specify anything down in the generics, because usually in the more modern versions of TypeScript, all of that can be automatically inferred. And if the types are written good, that will be inferred and you won't have to do it yourself. Okay, is that okay-ish? Okay, more or less, yes. Then I'll just jump over to the Redux part, and I'll just, again, jump out of the Redux part, because using TypeScript with Redux is something you can do, but something I wouldn't encourage you to do just with the Redux library alone, because there are a lot of libraries out there that somehow wrap Redux that have really great types and give you really much of a head start. And in the end, maybe you don't need to write any type in there, or maybe one. One of those libraries is a library that is going to be released tomorrow on ReactConf by the Redux maintainer, the current one. And we've been working on it for the last few months. I did mainly a lot of typings in there. That's Redux Starter Kit. It will hit version 1.0, I guess, tomorrow when he presents it. But it's absolutely stable, and I've been using it for over a year now. So I'm going to show you that and how, especially when using TypeScript, you'll profit from that one. So we add a Redux Starter Kit. Seems like I'm forgetting how to type here. And then we'll do the 3-minute very quick tour through there because our time is going to be up. So I'm importing some stuff from Redux Starter Kit, which comes with its own types. You don't have to install types Redux Starter Kit or something. It's written in TypeScript, so it brings its own types with it. And the first thing we might want to import is create action, because usually you would build all those action creators, and that's not really fun. So now you can do const my action creator equals create action with a payload of type string and type my action. And now we used to try to use this my action creator method. It tells me as payload I can only use strings. If I try something else, it will fail, and it will return an action with a payload of type string and the action already completely type everything set. So this is quite neat, but it's not the main feature, and it's a feature in the end you won't really have to use, because the main feature of Redux Starter Kit in my eyes is the create slice method. A slice in Redux Starter Kit is the concept like the DAX pattern of Redux, where you combine actions and action creators and reducers for one part of your state into at least one folder or maybe even one file. So we're going to do this here too. We'll say my slice equals create slice. And this really shows how absolutely beautiful TypeScript can be in the end. A slice has to have a name. I'll call it my slice. And then we just pass in reducers. And for each of these reducers, there will automatically be a generated action creator. So we just say we have our increment reducer here. And something's quite red. Because increment does not return anything. And we don't have a type of a state because we don't have a value. We can say our initial state here is 5. This state is just one number. Why not? And this is a reducer, so as a first argument it gets our current state, and then it returns a modified copy of the state. If I had a more complicated state, like value as a number in here, this obviously wouldn't work. I could, of course, do something like value is state.value plus 1. But these reducers here get automatically wrapped into the immer library, which means we can also modify state. There's a proxy around state that will catch any modifications we do and instead returns a modified copy of the state. So we could also just write state++ in here, state.value++, like this. We can also pass arguments in here, so we add an increment by, we get our state in, and then we get our action in, which is, here we need to specify a type, a payload action with a number as a payload. And then we can just state dot value plus equals action dot payload, which is a number. And we can use this in the end if we have our dispatch function available somewhere, which this obviously isn't, but I pretend to. We can just say dispatch my slice dot actions dot increment by 3. And you saw it, IntelliJ did everything for me here. I maybe did 1 or 2 characters per part of this, and I have complete type safety. I can't just increment by 3. This won't work, this won't work, only this works. I can't dispatch anything that's not in the actions, and this is one of the main features that saves a lot of code, a lot of headache, and a lot of indirection. And as I said, this is by the makers of Redux. This is not something that's anti-canon or something. This is how they want you to do it in the future. Okay, and I think we're through the hour. So I hope I showed you a few new things here and you learned something here. And I hope you have a great conference from now.